Mr. Lucy's chemistry. Yum 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 yum. All right, guys, welcome back to chemistry. Last time we left off, we were talking about naming. Okay, we had ionic naming, covalent naming, and acid and base naming, and it was all based on what the first element was. Remember, if it started with the metal, everything found on the left side of the zigzag line, we call those ionic compounds. If it started with an H, that means it was an acid. And if it started with a nonmetal, that means it's a covalent compound. Well, this time, we're going to reverse the process. Instead of you having to give me the name, you have to write the formula from the name. And that's the whole point, the juice of this entire unit, is so whenever you look at a chemical name, you can get the formula from the name because it's the formula that's actually super important, okay? So let me recap the ionic naming rules because it's these ionic naming rules that helps us get the formula from the name. Remember the metal. The metal always keeps its name. If it's a transition metal, that means one of these middle metals, you have to include the oxidation number in Roman numerals, okay? So there you go. Now the nonmetal, because that's what an ionic compound is, it's a metal bonded with a nonmetal. The nonmetal, if it's a single regular nonmetal, it takes an "ide" ending. Now if it's a polyatomic, it doesn't have the "ide" ending, it just keeps its name, okay? So from this is how we're going to determine what we're going to be doing, okay? Now quick recap with ionic compounds. Let me give you an example here. If I have a magnesium bonded, let's say, to a bromine right here, Br2, magnesium bromide. What happened here, okay? Remember when I said when these two elements hooked up, let me undo the hookup. We had magnesium, and if I come over here to magnesium, Mg, he has that +2 oxidation number. And that bromine right here has a +(-1) oxidation number, okay? So if I undo what happened, I have a magnesium with a +2 oxidation number and a bromine with a -1 oxidation number. This is how we started off. And then when the bromine said, ooh, look at that magnesium over there, and the magnesium said, like, oh, look at that bromine. They liked each other, so they wanted to react. They want to hook up. So when they did hook up, they switched phone numbers like that. And that's how we ended up with magnesium bromide. Remember, we don't write ones, okay? This is what we call swap and drop, where we swap the oxidation numbers and drop them down here, and we also drop the signs, the plus and minus signs. We drop that too. So we swap the numbers, and we drop them down, and we drop the signs. We call that swap and drop. So that brings me to today's new stuff, writing formulas, okay? Writing formulas. There are 3 rules if you want to write ionic formulas, and these 3 rules will help you write any formula, okay? Now, the first rule is this: you pull out the players. Okay? That means you take out whatever elements are in there. You can tell by looking at the name which elements are in there. So you pull out your players. Step number 2 is you're going to assign oxidation numbers. Okay? You're going to assign oxidation numbers. And guys, you don't have to guess at oxidation numbers. All the oxidation numbers are given to you. Okay? And even with the transition metals, those will be given to you. And I'll show you that when we do examples. So we pull out the players, we assign oxidation numbers, and finally, we swap and drop. Okay? We swap and drop. So there you go. You pull out the players, you assign oxidation numbers, and you swap and drop. Now, one big thing you got to remember, the nonmetals here, you have 2 options for nonmetals. You have a single nonmetal, which is found over here, which take the "ide" ending, and then you have polyatomics, which keep their name. Well, how do you know if you're dealing with a polyatomic or a regular nonmetal? Well, it's easy. It's all about this "ide" ending, okay? If it ends in "ide," you find it on the front of the periodic table, so it's a single element. And then you just use these oxidation numbers. If it doesn't end in "ide," that means it's a polyatomic. Okay? That means he is a polyatomic. So here's a list of polyatomics right here. Okay? Let's use nitrate as my example. It doesn't end in, you see, say I had barium nitrate. It doesn't end in "I," so I looked on this list right here, right? So I'm looking at nitrate here, and I'm going to look at the numbers. What is nitrate? It's NO2. You see this little dash? That means -1, okay? If you look at over here to manganate, it's MnO4, and he has a -2 oxidation number. So if it's just a dash, that means -1, and if it's any other number, it'll tell you. Like this hydrogen phosphate, he has a -2 oxidation numbers. So even when you're looking at polyatomics, they'll tell you the oxidation number. Okay? So that's all you got to remember. Pull out the players, assign oxidation numbers, and swap and drop. And check, does it end in "ide"? Single nonmetal. If it doesn't end in "ide," it's a polyatomic, and you look on your list of polyatomics, which will be included. Okay? So let's run some examples real quick. The only way to really do this is to run some examples. Let's look at example 1, magnesium chloride, right? So the first guy always keeps his name, so all I got to do is find magnesium. It's right here, Mg. He has a +2 oxidation number. So I'm going to pull out the player, Mg, assign his oxidation number, +2. I'm going to do the same for this chlorine right here. Well, is this a polyatomic or a single element? Well, let's look. He ends in "ide," so that tells me he's the single element chlorine. I'm going to go up, he's a -1, Cl -1. Okay? So now I've pulled out the players, I've assigned oxidation numbers. Now let's swap and drop. He's going to go here, he's going to go here. We have MgCl2. Okay? Remember, we don't write ones. Okay? So that was simple, right? Well, let's look at this other example right here, sodium sulfate. So we're going to look up sodium. He's right here. Remember, since these are ionic, I know one is over here, and one is going to be over there or on the polyatomic sheet. So sodium, I'm going to look, here's sodium. He has a +1. So I'm going to go Na +1. And then I'm going to look up sulfate. So I'm going to look. Oh, look. Sulfate does not end in "ide," so that means he's a polyatomic. So I'm going to pull out my polyatomic chart again, right? You could print this out at home too, guys. I've included it. So he is sulfate. So I'm going to look on my list. Here goes sulfate's down here at the bottom, right? So here's sulfate. Sulfate is SO4 with a -2 oxidation number. So I'm going to write down that over here. Sulfate is SO4 with a -2 oxidation number. So now, all I got to do is swap and drop. These two numbers, I swap and drop. So he's going to go here, and this one's going to go there. So I'm going to go Na2, SO4, and we don't write ones. There you go. Sodium sulfate. Okay? Let's look at another example here. Calcium nitrate. So let's look up the let's look up the element calcium. Here's calcium right there. He has a +2 oxidation number, so I'm going to write that real quick. Calcium, Ca with a +2. So let's look at this nitrate. Is this a single element or a polyatomic? Does it end in "ide"? Nope. So since it doesn't end in "ide," I know this is a polyatomic. So I'm going to pull out my polyatomic chart and look for nitrate. Okay? Nitrate right here. Here's nitrate. He is NO3 with a -1 charge, right? NO3 with a -1 oxidation number. So I'm going to write that down. NO3 with a -1 oxidation number. Now it's time to swap and drop these two numbers. So I'm going to go Ca, he gets a 1, right? and then NO3 is going to get a 2. But here's how the rule works. If a polyatomic gets more than 1, you have to put the polyatomic in parentheses. This is only for polyatomics. So I'm going to go NO3, and then I'm going to write my 2 that he gets, right? The reason why we do this is to keep, just so you know, this 2 is for the entire polyatomic right here, right? It's for everybody. And we don't want you mixing up this 3 and the 2, okay? So he got a 2 from calcium, so we put him in parentheses. Remember, use parentheses if there's a more than 1 given to the polyatomic. Here's another good example right here. Iron is a transition metal. He's found in the middle, okay? Now, if I looked up iron, you'll see he's right there, right in the middle of the transition. He's Fe. So I'm going to write down Fe. Now, here's the cool part. We know these transition metals have multiple oxidation numbers, but I don't have to guess. Why? Because they actually tell me what it is right there. So iron, that's the Roman numeral for what? There's 1, 2, 3 bars. So this is iron plus 3 right here. So that was easy. When it comes to transition metals, you don't even have to look them up because they tell you what the transition metal oxidation number is right there with that Roman numeral. Now sulfate, it doesn't end in "ide," so I'm looking on my polyatomic sheet. Let's find sulfate. Oh, look, it's out here at the bottom. He's SO4 with a -2 oxidation number. So I'm going to write SO4 with a -2 oxidation number. Now it's time to swap and drop. Remember, he goes here, he goes there. So Fe is going to get this 2, and SO4 is going to get that 3. But since it's more than 1, I got to put it in parentheses and put my 3 down there. Okay? And finally, our last example. Put a star by it because this one's special. Now, if I looked up magnesium, he's Mg plus 2. And now, we're going to look what this ending is. What does this end in? Ide. So that tells me it's a single nonmetal. Because it's a single nonmetal, I just got to look up here. This is sulfur, right? And he has a -2 oxidation number. So I'm going to write S with a -2. Okay? This one's super important. So let's swap and drop this real quick. We take our 2 numbers, swap and drop. We end up with Mg2S2. Now here's how the rule works. This one's special. If the 2 swap and drop numbers can be divided into each other evenly, we got to reduce them. Okay? Can 2 go into 2 evenly? Yes, 2 can go into 2 one time. So this will actually reduce out to MgS. Okay? This will reduce out to MgS. So I'm going to give you, say I had element X and he had 2, and I have element Y and he has 4, right? This can reduce out, can't it? What would it turn into? Well, let's look. 2 can go into 2 one time. 2 can go into 4 2 times. So it can reduce out. Okay? So you got to really pay attention to see if the swap and drop oxidation numbers can reduce out. Because if they can reduce, you got to reduce them. Okay? And guys, that's ionic formula writing, and I hope this helped.